Good afternoon, and welcome to our webcast, Reduced Reputational Risk from Data Breaches with the erwin platform. On our webcast today, we will discuss the importance of having a holistic approach of governing architectures that will protect your enterprise's reputation by understanding and managing private and sensitive data vulnerabilities. With me on the webcast is Alan Burnett, VP of Strategic Alliances for erwin Inc. Alan is responsible for developing strategic alliances in order to build the big data ecosystem at erwin. He came from erwin through the acquisition of Corso, where he was co-founder and chief operating officer. Welcome, Alan.
Thanks, Robert. Hello, everybody.
And following up on that is our next speaker, Don Soulsby, VP of Architecture Strategy, Sandhill Consultants. Don is our resident CMMI, DMM, EDME expert with a wealth of enterprise management knowledge. Over the 16 years that I've worked with Don, he has always been a man outstanding in his field. Welcome, Don.
Thank you, Robert. Hello, all.
In addition, you're listening to Robert Lutton, your moderator on this webcast, and this webcast is being recorded. By way of a quick introduction, Sandhill Consultants is an organization that can help clients build comprehensive data and enterprise architectures, leveraging governance, policies, best practices, standards, and procedures that will allow you to produce trusted, governed data. erwin Inc. is a leading data modeling software maker and is combining business process modeling, enterprise architecture, and data governance solutions to provide the only unified platform for enterprise data management. As we start this webcast, I'd like to take a moment to expand on erwin's unified platform for enterprise data management. In the context of information, data is being recognized as a critical asset to organizations. Organizations realize that they need to improve their management of data assets and how they will relate to the rest of the organization's systems, applications, services, processes, and technology. erwin is solving this need today by providing a new, intuitive, yet powerful data foundation platform that sits either on-premise or in the cloud. This offering enables data-driven business transformation via its shared capabilities of creating, editing, reviewing, charting, and reporting on the data, which are then leveraged by the additional modeling solutions that sit on top of the data platform. Today, we'll be talking about how organizations can leverage these solutions, with more to come in the near future, and how these offerings will enable organizations to solve a host of use case scenarios. And with that, I'd like to pass it over to Don, who will do a deep dive on one such scenario. Don.
Thank you, Robert. There is an old adage in journalism that good news never makes the headlines. And of course, you see the example here that we never heard about all the airships that didn't crash. Well, these are the headlines that we're starting to see today around data breaches, about cybersecurity, about breaches. We see the Yahoo with the millions of accounts that were breached. And more information that we're seeing in these headlines relate to these security or network breaches. Much like the horse leaving the barn and locking the door afterwards, a lot of what we focus on around data breaches is the actual data security. There's a comment here from the VP of Experience, Michael Broomer. The companies are no longer judged by whether they have a breach, but rather on how they respond when a breach occurs. An example of a headline from a few years back over in the UK was after the mad cow scare. This was an ad that was taken out in many of the large newspapers in England by the company Marks & Spencer, and basically in response to the breach, effectively, which was the mad cow scare, they said that you now can trust our meat because we can trace where the meat came from. In other words, we can trace it so you can trust it. And that's very much what the sample is here as we're looking at data breaches as well. Trust and traceability are very much involved when it comes to data. There's a recent statistic that was put out in the CEO.ca website that says that 2/3 of Canadian companies say they're losing the war on cybersecurity. Well, by any other name, whether it is data breach, security breach, network breach, really it is about people trying to reach into your organization and steal your data. In fact, by any other name, there's a new term for it called APT, which stands for Advanced Persistent Threat. So the cybersecurity threats, as we see, are growing day by day. In fact, if we look at some of the recent statistics, on the number of pieces of information that have been stolen from some very large and very well-known companies in the past several years, you can see the need to do something about this just in terms of the immensity of the potential for stealing data. Well, when things don't go according to plan, as we've seen in a number of situations, specifically if you remember the movie Titanic, when after the breach of the ice of the ship was noticed, the first thing that the captain and the architect of the ship did was pull out the plans. In other words, when things don't go according to plan, get the blueprints. That will give you a sense of where the breach happened, in this case of the Titanic, but also what the consequences of the breach are. And you need to know that from the point of entry of a data breach and what the consequences are to the amount of data that people are looking to steal. So in the data management world, our blueprints are actually our data models, our logical models, our physical models that can tell us what information was being breached, but not only that, what other information is associated or relative to that breach by the number of relationships that one individual piece of data or database was attached to. So when we look at data vulnerability then, we look to the classic risk assessment process of looking at the classification of the asset, its valuation, detecting how and where the breach might happen in terms of a vulnerability, but also how to mitigate it once it has happened. So effectively what we're looking at is the what, who, where, and how of a data vulnerability. What we're going to look at first, however, is the what, the classification part, which again in our case relates to data. So risk assessment in terms of classification. Somewhere in the set of principles related to data management in your organization, there is likely a statement very similar to one you see here, that data is a managed corporate asset. Well, if we look at assets at another example outside the data world, and we look at a pencil and a locomotive, clearly by the mass of the object, the mass of the asset, we recognize that one of them should have a higher level of management in terms of the asset than the other. In other words, a pencil will just be expensed versus a locomotive is a capital asset and needs a whole different set of management. So not all assets need to be managed the same way. In point of fact, with the large scale of data today, it is impossible actually to manage all of it all the same way. The volume is just too great. So if we look at data, we realize very quickly that data itself has no mass. The number of 137 can represent a number of different things, but by just looking at it as an asset, we can't tell the magnitude or the privacy or sensitivity of that asset. In point of fact, that number 137 could be 137 million, and it represents the sales revenue amount for a quarter within your organization. Well, that to me would be a very sensitive piece of information around which we want to put some assessment of the risk or data vulnerability to losing that information. Versus the number of cans of tuna that we did for a charity event last year, building a tower out of tuna cans. Now the reason we're recording that, of course, is because next year we want to do a bigger amount. So you can see that the same number, although represented by two different things, has a whole different set of risk assessments that is required for that piece of information. So if data is a corporate asset, one would think the most important thing you would have with your data assets would be a data inventory. In fact, it's becoming more and more data as we add to our systems, and we now have to deal with data in the lake, the big data per components, but we also have to deal with data in the cloud. So the data inventory has to be quite expansive to bring into account all of the data that we have, all of its connections in the data lakes, in big data, and in data in the cloud. So our data asset inventory, once again, as we look at the information, would be things something like this we have here, which would be a corporate view or a broad view of your data. We would call a subject area map that would show you in very broad context all of the information that exists inside the corporation. And in point of fact, one of the big data breach targets we see today is in the customer world, where people are trying to get into your systems to find the identifiers for your customers that will allow them to use them to go and look for and steal more information related to customers. We look here at one of the standards from the International Standards Association. For the financial data industry, we see their definition of a data dictionary, And you'll notice within the data dictionary we have these data types. Now the data types, as we know, are rather conventional pieces of information that we keep in the data management world, but you will notice that they're tied directly to a business element from a conceptual or business information system. And this is very critical to understand that data, although it exists in databases, and we have seen from the blueprints, our data models, also needs to be connected to the business. So if we look at that, then we see that we have business terms which come from a taxonomy or some other type of glossary, and we see the data elements. Well, we're very familiar obviously with the data element world, as we've seen from our data models. In point of fact, we see that data elements are related to other elements, and data elements are related to themselves in some sort of hierarchy. We've described that in the data modeling world as subject areas which each have entities, which are collections of things called attributes. And we describe that as a technical data model, typically a logical or physical data model. And those now we can see have a similar type of arrangement when we start to look at business terms. Most of the business terms you find in a taxonomy or a business glossary, frankly, are there to help you search. So in terms of those indexes for searching, we see that the corollary to a subject area is something called a business concept or a category. And within that, we see a broad business term, such as customer or product. And within that, we see these qualified terms, which effectively become our business terms or the elements of the business. So if we then look at the relationship between the business term and the data element, we see that in this business information model, again, which can take the form of taxonomy or business glossary, that we see a relationship then to the technical elements of the data management system, which are the data elements. But we notice that there is a many-to-many relationship potentially that exists of a single business term to multiple data elements, or multiple data elements can speak to one or more business terms. Well, we typically handle that in the technical modeling world with something called an associative entity. That's basically is the traffic cop between the business terms and the data elements, and fundamentally we can define those as critical data elements. Going back to the notion then that you can't manage all of your data the same way, a great way to prioritize or evaluate the information in terms of risk management is to identify these critical data elements. In the world of data elements, we know that we establish relationships between things by calling them keys. You have primary keys and foreign keys. We have a similar relationship that exists between business terms, and they're really the identifiers. So when we talk about patient ID or customer ID, they are the functional equivalent as identifiers to what we have in the technical data world called keys. So let's look then about evaluation of an element. And since we've now defined these as the relationship between business terms and data elements with a thing called a critical data element. What makes an element a critical data element? Well, first of all, there's the sensitivity. We need to look at that particular piece of information as to the level of confidentiality, or is it for internal use only, or frankly, is it publicly available information? The second key component in the risk relates to its accessibility. So from highly secure information, we would typically only provide that to the intranet, the internal system, behind the firewall. And secondly, if we also have to deal with partners, we may want to monitor the information in a thing called the extranet, which is the partner managed world. And thirdly, of course, in the unsecure world, we do have the internet. One of the big areas now that's become very, very critical is the understanding that private and personal information needs to be safeguarded. So in terms of privacy then, we'd look at personal information, and very important is the personal financial information, or frankly, is it non-personal or open, non-private information. Reliability is also very key to this. If you remember back to the picture we had from Marks and Spencer after the mad cow scare, was to note that trust and traceability are very much connected. Point of fact, what you see there is a pedigree from the American Kennel Club that says the high value animal that you have was a pedigreed animal, and point of fact is nothing more than the traceability of the different sires and parents of that animal. So in terms of reliability then, trusted data obviously is fully traceable. Do we need verifiable data? In other words, when asked, particularly by a government agency, can we show the path to that information? And thirdly, untrusted or unreliable information is frankly one that we need not have the mandatory nature of having it traceable. How do we identify our critical data elements? Well, today you probably already have them. They're in some of your business intelligence systems, and it's important to look at where and what you are reporting to the intranet, the extranet, and the internet. In point of fact, if we go back to our asset inventory, we could see that there is high value information being provided in some of these outputs from our business intelligence. Clearly one of the best places to go looking for that, because of the consequences of not following compliance, is to look at your regulatory reporting. And from that, again, try to glean the data that you would see in those regulatory reports, because very likely there are some of the elements of your critical information. Some examples we've seen, once again, the IDs, customer ID, patient ID, the social security number, and of course the credit card information. All are very much critical data elements that require a very high level of risk and understanding what the data vulnerabilities are. In most cases, these are the identifiers. If we go back to the business terms, these are the unique identifiers that help us understand from a business perspective what is the customer, who is the customer by these identifiers. Another place to look for your critical data element is likely if you have a program of master data inside those master data elements. There you will find these identifiers, your calendar identifiers, product, location identifiers, but very critically your customer identifiers. So within a transaction piece of information then, what we typically find is the date, a quantity, some measure of value of the transaction, but most importantly these master data keys. Keys and identifier is an interesting concept because in the business terms we tend to think of things as identifiers, which again is our equivalent to a set of keys. So in the master data structure, we see the different identifiers will form the key to those master data tables if you have a master data program. So we want to take a look at now from a practical perspective how we can deal with some of these data breaches and the vulnerabilities. The first thing we're going to look at through is the Erwin data modeler structure that we see here. Once again, these are mostly composed of the technical data models that start from the conceptual, the logical, and the physical data models. What we can do with the Erwin tool is to understand that we have a complete correct collection now of information from the databases physically, and then allows us to build a path of traceability back to the business glossary or taxonomy. So in the case where we have a data breach of a particular data structure or database, from a forensic perspective, we can take the database, reverse engineer it to a physical data model, connect it to a logical data model to see where other instances of that data exist, and then trace it all the way back to the business terms in the glossary or taxonomy to understand and rationalize the amount of risk and data vulnerability that we'd have, particularly where we have identified them as critical data elements. But more importantly then, if we've had a data breach in one instance, we could then take that information back to the business terms and look at other possible vulnerable areas as we've seen a breach happen in one particular database, and we have identified that these critical data elements were breached. We can then go back to the original taxonomy or the original business glossary and then see where those other critical data elements are in certain other databases, and then look at again to the vulnerability of those databases. So in other words, we can take a top-down approach by going from the business term, or we can take a bottom-up approach from a physical database, and by meeting in the middle at the logical data model, we can see now that we have this notion of concurrent engineering by being able to do the top-down and the bottom-up at the same time with the Erwin data modeler tool, and we can see complete connection then between the terms up top at the very highest level of business definition and right down to the attribute and the columns in a physical database. So how do we do that? Well, if the breach happens in a particular database, what we can do is take the database and put it through the reverse engineering tool, and then we can bring that information from the physical database into a physical data model. Now we have the beginning stages of those blueprints to help us find out what happened and where we can look at the vulnerabilities and the other risks. From there, we can then link the models from a reverse engineered physical model to a forward engineered logical model. Now, one logical model may have many different physical models, and that can happen as a result of physical geography or just using a different type of database tool that would require a separate physical model. But the linkage then to the logical model would then give us that capacity to understand from a reverse engineered data breach where there are other possible data vulnerabilities from the same type of information. We can also take a top-down approach, starting with a conceptual model, and this is where again we saw the subject area start to come in, where in very much business terms we define large clumps of data into something we call a customer, and then from there we can then forward engineer a logical data model from that conceptual model that now breaks it out into more finite structures. That, in fact, in the Erwin data modeling tool is called the design layers, where we can generate a logical model from that conceptual model. But if we look a little closer at one particular entity called person, we see that the social security number is highlighted in red. That would be evidence of how we can now add the notion of these critical data elements to our logical data models, that when somebody is using them now, we can see as they bring them into their models that we highlight for them that there is a critical data element here. How can we do that? Well, we can identify critical and sensitive data a number of different ways, but the one I want to show you here is using the UDP, or user-defined property. What I've done is I've created 4 of those separate risk evaluation structures: sensitivity, privacy, accessibility, and reliability, and provided them with a numerical capacity to say, on a scale of 1 to 5 or 1 to 10, how sensitive or private is this information. And once you do that, then you can then highlight the specific attribute in the entity with a color or a block or a change in character to then help people as they do their data modeling to understand that it does include some private or sensitive data. Once you've done that, then in your logical data models, you can load them to the Erwin web portal, and then by using a keyword search, you can now find where that information is in a number of different places. And we can see here by typing in the word customer, because we knew from our logical model that customer had a social security number, a highly critical and sensitive piece of data, that we can scan for where that is used. And we see now that it comes up as a primary key, a relationship, the name of a table, and some columns in a database. So now you can see we can do a complete scan of where and what our critical data is throughout the organization. Of course, we can also add a big data to this capacity by taking the processes and putting them into a big data structure, and using something like MapReduce, we can actually generate a data model from the seemingly random information and the very high volume of information that we find in big data. So let's look at what that provides us now. So the Erwin data modeling tool, using conventional modelings, and specifically coming from our traditional BI systems, where we do a lot of reporting, specifically again to government and compliance, and by using big data generating the model from something like MapReduce, we put it all together into this data foundation, and then from there, using the Erwin data governance portal, we can now see we have something called metadata intelligence that now provides us this linkage from top down and bottom up of all the information that we have in our data assets. And certainly we can then highlight them in terms of being critical data elements. So what we do then, for example, is we take something from the business glossary called a government identification number that exists inside the glossary, and we see that as implemented in a dimensional structure with a social security number. And then we can trace it back to its origin, which in this case comes from the accounts payable system. So we now see that how we can connect something called a term in a taxonomy or business glossary right down to a column in a database. Then with our selection of models, starting from the conceptual data model, logical and physical models, we can see now how that piece of information is distributed across our data assets. So once again, in the glossary or taxonomy, it's called a government identification number, but we now see we have several logical models that are dictated by geography, and the one of interest for us right now is the United States model, which we then see goes to the physical set of data structures and databases where this thing called the social security number is now implemented. So we can see if there happened to be a data breach of one particular area in one physical database. We can also see that there is potential vulnerability to that same piece of information in multiple databases. And that's called data lineage. So we now take our set of data assets, which are large and voluminous, and we can't figure out which is the most important, and we now create a more risk-governed set of data that has our business information models and our technical data models. What this allows to do is two things. First and foremost, it gives us that semantic lineage that says a column in a database through a series of models, logical and physical, relate to a business term. So we can see the spread and the lineage as it relates to a business term. But just as importantly, from a data breach perspective, we can also see where the data goes and how it goes, progresses from the starting stages of a database through the transactional structures down to the reporting systems. So that's what gives us the risk-governed data now and the identified critical data elements, the semantic data lineage, and the data movement lineage. In terms of a detection, though, things happen from a model perspective in terms of impact analysis, but that's actually not where the data breach happens. The data breach happens down at the physical data layer. It is in with databases that people go into to make the breach to try and steal the data. So it is more than just data in point of fact, because in terms of detection and mitigation, it's really about applications. It's typically through an application that a hacker has access to the data. In other words, it's a lot like having a gated community where the security system is on the perimeter, and once you breach the security system, you have pretty much free access to the things that are inside the gates. And a lot of that happens, again, with our application security. If somebody is able to breach the identifiers, we effectively have the keys to the application. So it's important to understand from an application level security, in the same way we did from a data security level, how things are connected. And there we look to the Erwin case-wise suite for business process modeling. So we can do a similar thing with applications that we did with our data, is we can take a forensic look at the application that was breached and then build it back upwards from the functional model to the systems model to the business models to tell us which business process has been affected. Obviously, that has some very big concerns. For example, if a breach happens to a specific application, to understand what the affected business processes are across the enterprise. So very similarly with the Erwin Data Modeler, we can do that bidirectional concurrent engineering. And as we saw, we can take our critical data elements from the logical data model that we've developed through the Erwin Data Modeler and pass them over to the BPM suite. Then the forensic work that we can do can be both from the perspective of the data that was breached, but also the application breach that happened. How does that work functionally? Well, we would take our logical data models from the Erwin data modeling tool, and we can actually bring them over to the case-wise BPM suite. And you'll see what happened as a result. By identifying specific attributes, we can then color much the same way we did in the Erwin data modeler, that in the BPM suite we can provide information as to which entities now have the critical data information in them. And within that, we can then highlight the sensitive data, and now we're looking at the case-wise screens here, and we see that we can specify that the entire customer entity we wanted to specify as sensitive. So it's more than just data now as we talk about tracing applications. So if I look at this activity monitoring application, I can then see the associated business process model. And that's critical to understand that as we look at the business process model now, what we see is the process flow, but you'll notice it also has entities associated with it. So if we look, for example, specifically at this process called check customer credit, we see in the upper right corner the fact that it is designated that it has a relationship to some data. As we highlight that and bring it up, we see that it's actual customer data, and if you remember, we had highlighted customer data as being sensitive. So now we start to see from a business process perspective where our sensitive data is included within which processes, and then by extension, which application implements them. It's also important to understand from data breaches is who is involved. Most importantly, who is your contact primarily if a data breach happens. So if you get the information from your network operations center that a breach has taken place, it's very critical to understand the path back to the business process. And in this case, we highlight that there is a data steward associated with that piece of data, and their person's role is the chief accountant. So from looking at the specific roles then, what we can do in terms of a breach is now highlight the fact that the accountant was the data steward and needs to be notified, and then within the case-wise BPM suite, we can specify their contact information, and this can be an automated process. So we've taken a pretty in-depth view of data and application in terms of our capacity to do some forensic work in terms of the bottom-up recognition of something that happens either from an application breach or specifically some data is stolen from a data breach. And we've taken a fairly deep dive into both the data and application. But to get a better sense of preventative measures, we need to really take a broader view of that. So what we've seen is the information that we've used in the Erwin Data Modeler for data and the Erwin Case-Wide Suite for business process modeling. But we need to take a better picture of that. What we've really looked at so far is just the solutions architecture of the databases and applications, and more from a forensic perspective. But clearly we need to take that solutions architecture and provide a bigger picture of where we can look at the potential of these data vulnerabilities. And therefore we need to take a look at things like security and network, some of the technology architectures to help that. So in point of fact, what we really need to do is broaden the scope of this and get the bigger picture, and that's where I'd like to take a look at the Erwin Agile EA. At this point, I'd like to pass over to Alan, maybe give us a better idea now of how we can do that bigger picture.
Thanks, Don. Yeah, so as you've explained, we've looked at the in-depth architecture, and that's vital to understanding the nature of any breach. But what I want to talk about in the next few slides is really how can we communicate this to a broader set of stakeholders, whether that be security teams or even the business itself, so we can understand the full impact of a potential breach or multiple breaches, and actually how can that impact our ability to operate as an organisation. So to do this, we bring in another tool called Erwin EA. That's Agile EA. It's a SaaS-based tool that's focused on enterprise architecture. And you might ask yourself why you need enterprise architecture at this stage, but what we're trying to do is broaden this up into a high level of abstraction so we can focus on the bigger picture. So although we've seen here the nature of entities, physical, logical entities, applications and processes, we actually want to bowl that up to look at our ability to operate through the services and capabilities that the business has and create an extension of the lineage or linkage across those so that we can build a picture of when there's a breach at a database level, how does that bubble up to the actual capabilities of the business, and we can see the impact of that on a very large scale. So it's important that we have a tool. Erwin EA is a SaaS-based tool, so it lends itself to the business stakeholders who need to focus on a particular outcome or scenario in the model. One of that such scenario could be a data breach. There could be a whole number of other scenarios that an enterprise architecture is looking at, but this is one of the key areas. So we need a tool that visualises the impact across that business. And really, it's important when we're talking to external stakeholders that it's not just some of the detailed, complex diagrams that we've seen. So we want to see diagrams, perhaps, or models that are a little bit more expectation of, that it's, as you can see, an example capability map where you've got a box-in-box view, a business on a page view. So we can understand, and you can see some of these colours here, that some red and green, where the potential breaches and how they might impact a particular capability. So although we know that the breach is being caused in a database somewhere, how does that actually impact the business? And that's what we're seeing here. So we're seeing in our customer care capability, there's some key, or a couple of breaches that could potentially impact. In fact, there's a couple of breaches in our claim management capability. So it's very serious, and it exposes that to senior stakeholders. So we can convey the big picture. We're trying to do it in terms that people recognise. So this kind of value chain approach is a common approach to looking at your business as a whole. And putting heat maps on top is a very good way to allow people that have no real knowledge of the detail behind that breach, but need to understand how it impacts that business. So it's an excellent way to communicate with some senior stakeholders that you know, if we presented to them the solution around the detail, the in-depth architecture is vital to how we need to build our models. It wouldn't make any sense to that stakeholder. So then we have some alternative views. So again, part of the core part of the Agile EA tool is the ability to focus on particular scenarios. So if we're looking at a breach, we can look at how does that affect the business, but visualize that in different ways. So it could be from a perspective of how can we deliver this particular capability. So we've got a timeline in terms of the applications that support that capability and how they're affected by various breaches, or how they're affected in how does that affect our ability to build that, or what do we need to build into a particular project or program to ensure that we don't build any such data breaches in the future. So our roadmap, which you can see in the top right-hand corner, that's automatically generated from the data that's within the model, allows us to again engage with different stakeholders in different ways. We can see just below that there's the Kanban approach. So as we're looking at how we might deliver a project and program and building that risk and how we might mitigate that risk, we can see we actually have to go through different stages of delivering and understanding how we're going to build that into a program and project. And all this is part of the Agile EA piece. But importantly, it allows us to link right back down still to the data and the data models that we have. We're just trying to bubble it up to a different level. So it allows us as an architect or from a project management perspective or from a security perspective, understand any prioritizations we have to make. As we drill into the model, we can see some of the hidden dependencies that across projects and programs that are affected by data breaches. And then on this slide, the last point I really want to make is the importance of how do we design our future systems to mitigate these breaches. So on the left-hand side at the top there is the current architecture. On the right-hand side is a future architecture. So what we use the Agile EA tool to do is to understand the difference between the as-is and the to-be and build in a project and program how we're going to move between those 2 points. So how are we going to deal with those breaches? What projects and programs are we going to put in place to understand which parts of the architecture we're going to affect? So it allows us to build a roadmap for change. So what we're trying to do is trying to build in an understanding of in the future architecture that we build, in the future systems that we build, we need to be cognizant of what we've understood from the high-level knowledge from the data breaches that have been exposed. So we make sure we don't build in any known issues or vulnerabilities into future architectures. And then finally, again, it's different ways to show the different information to different people. So some people are visual, some people are numeric. Again, the tool is very flexible in the way that it tries to expose that detail. Again, just more tools, more the ability to get to broader stakeholders. And really, what we're trying to do is understand, how does any breach or potential breach affect our ability to operate as an organisation? And that's what you bring the Agile EA tool in to do for you.
Thanks, Alan, and thanks, Don. So for our audience, what Sandhill is seeing is a need for enterprise-level governance for data, application, network, and security. From a high-level point of view, Sandhill and Erwin offer a holistic approach to providing governance architectures from an enterprise perspective. Data breach is just one example of many scenarios that call from a firm foundation in data architectures. And many organizations often wonder where to begin. So how would you get started? The way that Sandhill views this is first you need a map. And that's where we leverage our enterprise management expertise and the mature framework of CMMI and the data maturity model, DMM. Combining both of these options, we can then assess where a client is, where you want to go to, and how to get there. The DMM assessment assesses 27 critical different key areas, including strategy, quality, operations, architecture, and governance, and evaluates where you are on a scale of 1 to 5, and no, you can't be less than 1. It outlines how we can mature you to level 3, and should you wish to go to level 5, you can do that. But level 3 provides an enterprise-wide data management capability, a target where most organizations are looking to achieve. Sandhill consultants have the expertise and the platform and offerings to help organizations protect their data and their reputational risk from data breaches. And we can also help you manage the context of the data within your organization. Sandhill consultants in conjunction with Erwin offer the ability to leverage these solutions and combine them with our capability delivery systems to mature your organization to an enterprise-wide data management capability. For more information on DMM Assessment or the products mentioned such as Agile EA, the Case-Wise Suite BPM, and Erwin Data Modeling, please contact me at the following email address. And with that, we're just going to go into Q&A, so I'm going to stop the recording here. But I would like to thank both Alan and Don for their participation in this webcast and for their content. Thank you, guys.